page 4. Here we are. Okay, so now we're getting into more of these math problems. It is going to be important for us to note these equations as we go along. So the first question that I have for you up here is, point along the roller coaster, will it have the most gravitational potential energy? This one was pretty easy for everybody. Point 1, most gravitational potential energy, because it's the highest. It's at the top of the hill. So up here, most potential energy, gravitational potential energy, because it's the highest up. Next, the next part was where are we going to have the fastest speed? Which 2 points? And I was looking for 2 and 5. At both 2 and 5, those are the positions at the bottom of the hill, here and here. Those are the lowest possible ones, and they should be the same height. I want those to be the same height. And so if they're at the same height, then we should theoretically have the same speed at both of them if there's no friction involved. So that's what I'm looking for number 3. Some other answers we had were the potential energy, which doesn't necessarily mean that they have to have the most speed. But I really like this particular answer. The coaster is coming down a hill, so it will have a lot of kinetic energy. That was a really good response. Because they're coming down the hill, that's what's giving them the kinetic energy. Both after tremendous slopes, making them have the most kinetic energy. So that's another good response here. Then we get to why might the roller coaster be going slower at position 5 than position 2? I do really like this response. Because the kinetic energy was lost, some of the energy was transferred to other forms such as thermal energy. That's a good response here. Another student said lost to thermal energy. What I'm really looking for here is that because of friction, you're going to lose some of that kinetic energy or mechanical energy to thermal. Some folks put down because it went through a loop, which made it lose some momentum. Not necessarily. If you don't have any friction, then you would be stopped here, then in all gravitational potential energy, and then at the bottom, all of that would have transformed into kinetic energy. So this is all potential, this is all kinetic. And then you get up here, and this is going to be some potential and some kinetic. And then when you get back down here, this is back to being all kinetic again. So you lose some of that energy as you're going up, but you gain it back. And so if there's no friction, then these would be actually the same amount of kinetic energy and therefore the same speed. But because of friction, you're going on this path a longer distance, you will lose more energy to friction while you're going through this loop. And so that is why you do lose some momentum going through the loop. It's because of friction. It's not just because you're going through a loop. Okay. Next question is, the roller coaster has a speed of 25 meters per second at position 4. What is the kinetic energy of the car at that point? So we are going to need our formula for kinetic energy, which is this one. Ke equals 1/2 times m, which stands for mass, times velocity squared, which stands v squared, which stands for velocity squared. And so then to calculate that, we just need to show the formula. Then we plug in our numbers, 35,000 kilograms and the 25 meters per second for the velocity. And we get our energy in joules. And then in the next question, we have, I need to fix this real quick because, sorry to the student, this is so cruel, but that unit for when we get to momentum, that unit is kilograms times meters per second. So when we're calculating momentum, momentum is not energy. It is a different quantity. and it's P equals mass times velocity. And the unit there is just the unit for mass, kilograms, times the unit for velocity, meters per second. So it is not joules, it is kilograms times meters per second there. Then last question on this page is at position 12, at position 4, we're 12 meters off of the ground. What is the gravitational potential energy at that position? Okay, so that's going to be mass times height times gravity, or mass times gravity times height. It doesn't really matter what order that's in. This should be an equal sign right here. Okay, and so that's going to be our mass times acceleration due to gravity times 12, and that gets us our potential energy in joules. So energy is joules, but momentum is kilograms times meters per second. So this value here, kilograms times meters per second. Okay, that is the end of this page.